From the previous units of the course, we have learned what a computer is made of. Everything we know so far will give us an intact computer, ready for use. But what really brings a computer alive? P.S. It's not just electricity. The fundamental use of a computer is to work for us, to carry out our instructions. The computer will execute exactly as it is instructed to, hence, the task must be explained in a series of detailed steps. So, a computer program, in simple terms, is a list of instructions for the computer to perform. All the programs used by a computer are collectively called software, and all the tangible components of a computer are called hardware. We learned earlier that computers understand everything in the form of zeros and ones, which is called binary code. However, it is difficult for us humans to write out instructions in binary code. That's why a midway solution has been created. Like the perfect solution giving you complete comfort and ease, D. Instructions are written to the computer in a language that is partly English and partly contains connotations understandable by a machine. This is called a programming language. Since it cannot be directly understood by the computer, it has to be translated into binary code before execution. This translation stage is called compiling and is done by a program called a compiler. Compilers did not always exist, as the early programs were written in machine language, binary code, itself. Just like computers, the programming languages that run on them have evolved too. They are divided into generations to indicate the increasing power of programming styles. First generation, machine-level languages, low-level. Low-level language, very close to binary. Third generation, high-level languages that are machine-independent. Fourth generation, high-level language, very similar to English. Fifth generation, high-level contains tools to help develop a program. First-generation programming language is a direct example of instructions in binary. It is called machine-level language. The second generation is written in a code very similar to machine language and needs to be compiled before use by the computer. It works only for a particular version of a computer. Third-generation languages are high-level languages. They are machine-independent and can be compiled to run on different versions of computers. Fourth-generation languages are very similar to statements in English and are mostly used in database programming and scripts. Fifth-generation languages contain visual tools to help develop a program. Commonly used for developing artificial intelligence applications, they are based on a set of rules instead of instructions. If a task is considered as a list of instructions, the job of a programmer is to develop this list of instructions in a computer language. The instructions need to direct the computer to manipulate different types of objects like numbers, images, words, sounds, etc. Sounds like the work of a music composer directing each instrument? Well, in a way, that's what a computer programmer is. Before beginning to write a program, we need to consider what we want the program to do. Identify the problem, what is the task that has to be executed? Identify the user, what is the profile of the person who will use this program? Identify target machine, which computer will it run on, type, whether iOS, Android, etc. Which language is it best to employ? The fourth step will be much clearer once the first three are done. If you were to tell your friend to drink a glass of water, what would you say? Probably drink some water. Now consider that this friend of yours is actually a robot. Does your statement alter slightly? What if your robot friend asks you, what do you mean by drink? You would have to be more specific, wouldn't you? So let's try to be clearer. Let's say to the robot, get up from where you are sitting and go to the kitchen. Pick up a glass from the third shelf, using one hand. Pick up the jug of water with another hand. Pour water from the jug into the glass until the glass is full. Bring the glass near to your mouth, tilt it and swallow the water. Not really. Because now, our robot friend is standing in the kitchen, still trying to drink water from an empty glass and the jug is still in his hand. Remember, a computer will do exactly as you say, and nothing more or less. It could be argued that writing a computer program is as much an art as it is a skill. Let's try again. The objective of your code is to make your robot move one step to its right. Instructions. Get ready to move. Pick up your right leg and place it 30 centimeters to the right of your current position, along a linear path. Now move your left leg and place it next to your right, assuming your original pose. Say the words, I have moved to my right. Stop executing. Now this is more like it. It's interesting to note here that the robot must already know what right leg means, how far 30 centimeters is and what a linear path looks like, etc. Details like these need to be stored in the computer's memory, just like we learned in the previous unit. The writing of a program will be explored in greater detail in the advanced course.